Thank you.
Welcome, gentlemen.
Thank you.
How much more standard can it get with a flip chart, huh?
A classic one.
Okay, you guys have fun.
Thank you so much. Good morning, everyone. My name is Felix Kranert.
And I'm Stefan Schott. Standardization is the basis of digitalization. And that's why we want to talk to you about standardization in the area of automation. So all along the digital workflow, starting at the planning and construction, over to the engineering, the testing and simulation, and of course ending up at the integration of a machine into a line. And we will do this with examples and experiences we made while building up this machine, our tier digitalization demonstrator. We also have this machine over there at the booth, and with this machine we have identified and created several use cases all around the digitalization.
When we started to implement our digitalization use cases in that machine, we were working with different people and different teams. So for example, we had one team working with the tier selection tool, selecting all the components. At the end of the day, they were creating the bill of materials. We had a second team working with an ECAD system, so they did the whole construction. And last but not least, of course, we had our software engineers working within the TIA portal and creating all the software components we need to realize our automation solution. So far, nothing really special. But the challenge with that setup was that when we had a change, for example, for only one hardware component, it was very hard to synchronize them all again because we had to do the changes manually in all the teams. And today, I am very happy that when we would start that project again today, we wouldn't have these issues anymore, because now, thanks to AML, automation markup language, we are able to send, for example, the hardware data information to the tier portal from the tier selection tool, or we send the hardware information from tier portal to the ECAD system, and of course, due to the fact that it's a standard, we can exchange the data, of course, here between tier selection tool and our ECAD system.
So Automation ML is a standardized data format for the exchange of hardware data between tools usually used in planning and construction. An AML file can contain the network planning, the hardware configuration, and even the symbolic names of our PLC tags. So all data which is used in different tools. And instead of creating this data in each and every department, we just do it once. We do it once, transfer the data to the next tool using the AML format, enriching the data, and transfer it further until we end up in the automation department. So we do not only reduce potential causes of errors and get a higher quality in the early phase of planning, we also reduce redundant work in the departments and get free resources at our employees.
So that was very quick. Now, hardware components selected, and Stefan, you know that already. Now it's becoming real fun. Because in that time of the process, we cannot rely on an existing standard like AML. Furthermore, it's the job to create our own standard. Stefan, have you already configured your car of dreams online?
More than once.
I guess, yeah. So, you know a car configurator online. And this is the perfect example for that, what we are going to do now. Because when you go online and you configure a car, you have several options. You can choose, and at the end of the day, very often you have a totally different configuration. And the fact is, when you, for example, you choose a sunroof, every time you choose that, you get the same sunroof. Due to the fact that the single components in a car are standardized. And this is exactly what we are going to do now with our automation solution. For that, we start once again with the TIA portal as the central gateway. And in the first step, we are using TIA portal's integrated library functionality. Within that library, we have everything what we need to realize our application. PLC blocks, HMI components, data types, everything. And now comes the fun part. Because due to TIA Portal's integrated API, application programming interface, you are able to create your own configurator for your automation solution. So with that tool, you're able to send commands directly to TIA Portal, and based on that, TIA Portal will fully automatically generate the final project for that automation solution.
So the basis for the automatic execution are the integrated TIA Portal libraries and the elements. Our API, the TIA Portal openness, lets you use the functionalities of the TIA Portal from external sources. An external source can be an XML file,
sure,
but also your own tool or configurator which suits your individual needs. Honestly speaking, you need programming skills to do so, and they are not always available. But with the Openness Scripter, a free of charge tool, we offer you the possibility to use this API without any programming skills necessary. So everybody is now capable to use the automatic execution and create your own program automatically. And in the next step, the HMI creation, we can use CVARC, the Semantic Visualization Architect, to even generate our HMI fully automatically. CVARC scans the PLC code for the functions used and then selects the elements out of the libraries to create your own HMI. So that's how we get in record time from scratch to a fully operational machine.
Exactly, and this is very, very much power for our engineering workflow. But Stefan, to be honest, even when we generated everything based on a library with standardized components, I think it's still necessary to do some final testing, right?
Sure.
And for that, once again, we start with TIA Portal. And at that time, we are using TIA Portal's integrated simulation functionality. So for example, when PLC code is finished, you can use TIA Portal's PLC Sim to check all the logic of the program and everything, controller logic. With TIA Portal, you can also simulate your whole HMI. So when you're ready doing your HMI components, you can test that before. But only for single components, so you can test the PLC and the HMI. It's becoming a little bit more complex when you want to do a simulation of the whole solution, of the whole machine. Today, we call that the digital twin. And to do that, you need some simulation tools which are able to simulate more devices at the same time and also simulate real behavior. For example, this can be PLC Sim Advanced, or this can be, of course, also SIMIT. And with that tools, you will be able to send, again, data, for example, from TIA Portal, use your PLC code to these simulation tools and bring that digital twin to life, actually. And with that, you get knowledge out of if everything is working, and you can send that back to the development departments to improve what you developed.
So we offer you a scalable solution for simulating and testing all around the TIA Portal. For simple logic tests of your program or the simulation of your HMI, you can use the integrated functions of the TIA Portal. If you want to test your controller against a behavioral model, or even a simulating tool to bring life to your digital twin, then you need to use PLC Advanced. And if you're looking one step further, PLC Sim Advanced can not only simulate one controller, we can simulate several controllers. And with that, also the communication between them.
And communication is exactly the right keyword in that situation, because even when we are finished with our single machine and automation component, on a real plant, we often have the situation, for example, that we have one machine coming from one manufacturer, but we have also other machines coming from different manufacturers. And for that, it does only make sense to build up the communication based on a standard, in our case, OPC UA, which allows us to implement a standardized data interface as a major part of our machine. And this is possible with the OPC UA Companion specifications.
So the standardized language for machine communication is OPC UA. But those interfaces, where do they come from? Well, actually, they come from you. You can decide for yourself to create your own company standard and help your customers and your service crew to easily integrate your machines into the final solution. But you can also rely on internationally standards, industry standards, the so-called companion specifications. These companion specifications define the interface for a whole branch of machines. PACML, for example, for the packaging machines, Euromap for injection machines, robotics are coming up, and many more. So how do we get these interfaces now into our controller? For this, we use the Siemens OPC UA modeling editor. Again, a free of charge tool in which you can define your interface on the one side or import the companion specifications and then simply map the PLC data onto this interface. The result can be exported and downloaded into our SIMATIC controllers using the TIA portal.
You heard standard or standardization very often within the last minutes. And to be honest, standardization, that does not sound really cool, right? But on the other hand, it sounds like a lot of work to do. And yeah, that's true. But due to the fact that standardization is the basis for digitalization, you can get a real power boost for your whole engineering workflow with that.
Exactly. And standardization, we've just seen only a few examples. Standardization has many phases, and that's why it's also the basis for digitalization. And we want to invite you to come over to the TIA digitalization demonstrator. We will be there and many more colleagues, and we can get into detail on how standardization helped us improve our machine building.
Absolutely. So thank you very much for joining our presentation, and we're excited to see what's coming up right now.
Siemens, ingenuity for life.